All right. So sine of 7 pi over 12 is sine of 4 pi over 12, sine of 3 pi over 12, which is a sine of pi over 3 plus pi over 4, which is sine of pi over 3 cosine of pi over 4 plus cosine pi over 3 sine pi over 4. What's sine of pi over 3? Come on, people. What's sine of pi over 3? Square root of 3 over 2. Cosine of pi over 4. Cosine of pi over 3. Sine of pi over 4. So it's the square root of 6 over 4 plus the square root of 2 over 4, which is the square root of 6 plus the square root of 2 all over 4. Bada bing, bada boom. 11. Tangent of 75 degrees. Okay? Which is the tangent of 40 plus 35, or 30 plus 45. Do you want to do that one? No, you don't want to do that one. There we go. I like how you people think. 120 minus 45, because we'd rather not use 30 or 150 if we can. Okay? So this equals the tangent of 120 minus the tangent of 45 over 1 plus the tangent of 120, tangent of 45. Tangent of 120 is negative what? Minus 1 over 1 plus square root of 3 times 1, which is negative square root of 3 minus 1 over 1 plus the square root of 3. What do we have to multiply both the top and bottom of that by? Conjugate of the denominator. I'm going to switch the numerators order. Since they're both minuses, I'm just going to switch their order. So I'm going to multiply this by 1 minus the square root of 3. So if I FOIL, 1 times negative 1 is negative 1 on top. Outers is plus square root of 3. Inners is plus square root of 3. Last times last is, did I do something wrong? Yeah. So negative 1 times 1 is that. Outers is positive square root of 3. Inners is negative square root of 3. Oh, there, yeah, Miles, you're right, and I just didn't see what I did. It's 1 plus negative square root of 3, so it's 1 minus square root of 3 on the bottom. Thank goodness you have a Miles in class. Minus square root of 3, so this is plus and plus, because I knew something just didn't look right. All right, negative 1. Outers is negative square root of 3. Inners is negative square root of 3. Last times last is minus 3. All over 1 plus inner and outer cancel, minus 3, which gives us negative 4 minus 2 square root of 3 all over negative 2, which is 2 plus the square root of 3. Now, how can I check my answer to see if I'm right? Plug it into your calculator. Take the tangent of 75 degrees on your calculator. Take 2 plus the square root of 3 on your calculator. Let me just do that right here. On. And I got to make sure I'm in the right mode. I'm in degree mode. So I go tangent of 75 degrees is that. And if I go 2 plus the square root of 3, I get that. They're exactly the same, so I got the right answer. So if you ever wonder if you get the right answer, you can check on your calculator, see if your answers match. All right, 13, a little easier. the sine of negative 15 degrees. Why am I writing tangent when I'm saying sine? I don't know. The sine of negative 15 degrees. What two numbers subtract to be negative 15 degrees? There's a bunch of them, but what are two easy ones? 45 minus 60. Or you could go 30 minus 45. Either way. So it's the sine of 45 cosine of 60 minus cosine of 45 sine of 60. Sine of 45 is square root 2 over 2. Cosine of 60 is 1/2. Cosine of 45 is square root of 2 over 2. Sine of 60 is square root of 3 over 2. So it is square root of 2 over 4 minus square root of 6 over 4, which is square root of 2 minus square root of 6 all over 4. And again, if you want to check on your calculator if that's right or not, you sure can. And the last one, 15. The tangent of negative 13 pi over 12. Okay? So, what two numbers subtract to be negative 13 pi over 12? Very good. 4 pi over 12 minus 9 pi over 12. Oop. 4 minus, it's negative 4 minus 9 works. 4 minus 17 pi over 12. We don't know a 17 pi over 12, so that wouldn't work. That works best. So the tangent of pi over 4 minus 4 pi over 3. Because we want the denominator to be a 3. Because otherwise we get really complex fractions going on. So it is the tangent of pi over 4 minus the tangent of 4 pi over 3 over 1 minus the tangent of pi over 4 tangent of 4 pi over 3, which equals square root of 2 over, no, it equals 1. 1 minus negative square root of 3, right? Over, and this should be a plus on the bottom, 1 plus 1 times the negative square root of 3. So I have 1 plus the square root of 3 over 1 minus the square root of 3. What do we do top and bottom? Multiply by the conjugate of the denominator, 1 plus square root of 3. So you get 1 plus square root of 3 plus square root of 3 plus 3 over 1 minus 3, which gives you 4 plus 2 square root of 3 over negative 2, which is negative 2 minus square root of 3.
Be a negative square root of 3 in this situation beginning because it's negative square root of pi over 3 over negative 1/2. There's two negatives there in the tangent.
Boom, roasted.
Yeah, I'm roasted. I don't even see where I'm.
4 pi over 3, it wouldn't be a negative square root of 3.
Oh, no, it's a positive square root of 3. Boom, roasted. Okay. So that's a plus, and these are both minuses. And the top up here is a minus. And so minus minus 1. Outers and inners are both minuses here. So it's 4 minus square root of 2. The bottom doesn't change. So it's negative 2 plus the square root of 3. How about that? I would have figured it out because once I went in and did the tangent, of, what did we start with? Negative 13 pi over 12. So we go negative, no, that's not a negative sign, negative 13 pi divided by 12 is that, and negative 2 plus the square root of 3 is that. Uh-oh. No, we got to be in radian mode because we're not in degree mode. So we go mode, go down to radians. Hi, Neely Solomon. And we go back up to this one and hit it again. And now it matches. Okay, so we're good. Okay, today we're doing double angle formulas and half angle formulas. Last new stuff for the entire year of Trig. Spring semester kids have to learn more. They have to do more. They have to do another 2 or 3 sections because they have more time. We just don't have the time to cover those 2 or 3 sections. So section 3.5A. I'll do 3.5A now. I'll do 3.5B after a little bit. We're going to do the double angle identities.
This is recording, right?
Yep, I'm recording it for Abby.
This is a video of Abby.
Okay, there we go.
Say hi.
Bomb Quest. Bomb Quest. All right, note card, get out your note cards. Well, you have 10 more formulas to put on your note card. You might have to put them on the back then. All right, so this section is called double angle identities. Five now, 5 later. The sine of 2x equals 2 sine of x cosine of x. The cosine of 2x has 3 different formulas. We could say it's the cosine squared of x minus the sine squared of x. We could say it's 2 cosine squared of x minus 1. Or we could say it's 1 minus 2 sine squared of x. And the tangent of 2x is 2 tangent of x over 1 minus tangent squared of x. Okay, I'll leave that on the board for a few seconds because I know I just bypassed about 20 of you in here. All right, here we go. Now, basically, double angle identities, I shouldn't have to teach them, but I'm supposed to teach them, so I do teach them. But they're almost worthless to teach because we know the answer before we even start. What is the cosine of 60 degrees? Everybody can look at your note card and see that it is 1/2. Now, using double angle identities, what I'm supposed to do is take it as the cosine of 2 times 30 degrees. And you're going to have to do you're going to have to show double angle identities on your test. You're going to have to show each step, so you do have to learn how to do this, even though you know the answer already. The answer is going to be 1/2. All right. Then you look at your formulas and you say, which one do I want to use? Generally, I like to use this one best. Okay. Usually I like the second one best on that list. So I'll go, the cosine of 2 times 30 degrees is 2 times the cosine of 30 degrees squared minus 1. Because 2 cosine squared of x minus 1 means you take the cosine and you square it. Okay? Well, what's the cosine of 30 degrees? Square root of 3 over 2, and we're going to square that. Square root of 3 squared is 3. 2 squared is 4. What's 2 times 3 fourths? 6 fourths, which is 3 halves. What's 3 halves minus 1? And that's the answer that we knew before we ever even started the problem. Okay? So you'll know the answers to these before you even start the problems, for the most part. Okay? Let's do the tangent of 2 pi over 3, which is equal to tangent of 2 times pi over 3. Now, I got to look at the formula because I don't remember it. 2 tangent of x minus 1 tangent. So you go 2 tangent of the new thing, because the new thing is pi over 3. Because you started with 2 pi over 3, which is 2 times pi over 3. Okay? Over 1 minus tangent of pi over 3 squared. Okay. So far, so good, right? The biggest thing is knowing how to turn 2 pi over 3 into 2 times pi over 3. Besides that, you just plug it into a formula. So it's 2 times tangent of pi over 3 is square root of 3 over 1 minus square root of 3 squared. So it's 2 square root of 3 over 1 minus 3. So it's 2 square root of 3 over negative 2, which is negative square root of 3. Is the tangent of 2 pi over 3 on your unit circle negative square root of 3? Is it? Yeah, because it's square root of 3 over 2 over negative 1/2, which is negative square root of 3. Okay. Can you handle this section of it? I'm only going to give you 7 quick problems. 1 through 7 odds on page 193. This is the easy part. In 20 minutes, in 20 minutes, I will cover half angle identities, which is a little trickier. Okay? So on your mark, get set, go. Get to work.